Black holes are quite an amazing and scary part of the universe. Apparently nothing, not even light, can pass through a black hole. Now, a lot of you out there might have many questions about black holes, but one that recurs the most is, what happens if a person falls into a black hole? Some say that the person's body stretches in long strips like spaghetti, but is it really true? Stick till the end of the video to find your answers. Hello and welcome to Tipsy Alien, where we discuss the most mind-blowing facts about aliens, extraterrestrial life, and space exploration. Subscribe to our channel and press the bell icon so you don't miss future updates. Without further ado, let's get straight into black holes. Black holes are named black holes because they do not reflect or emit light. They are only visible when they feed on stars or gas clouds too close to their event horizon. Beyond the event horizon is a truly minuscule point known as a singularity, where gravity is so intense that it curves space-time itself infinitely. This is where the known laws of physics fail, rendering all theories speculative about what lies beyond. Most of us find black holes strange, but scientists are used to them. For decades, physicists toyed with theories about similar objects before Albert Einstein's general relativity predicted their existence. However, the concept was not taken seriously until the 1960s, when extremely compact stars were discovered. Today, black holes are considered a normal part of stellar evolution, and astronomers believe our Milky Way galaxy alone contains millions of them. Black holes are created when small, dense remnant cores of dead stars collide. If the core's mass exceeds about 3 times the mass of the Sun, gravity overwhelms all other forces, causing the remnant to collapse and create a black hole. Black holes are extremely dense objects with so much mass that they have a strong gravitational pull that even light becomes trapped. Most spiral and elliptical galaxies, astronomers believe, have black holes at their cores. There are 3 kinds of black holes. Stellar mass black holes are the smallest, weighing between 1 and 100 times the mass of the Sun. They come into existence when the core of a large star collapses, resulting in a supernova. The largest, known as supermassive black holes, can have masses that are millions, if not billions, of times the mass of the Sun. It is thought that this type of black hole reaches its enormous size by merging with other black holes and subsuming stars. Intermediate mass black holes are a third category that, as the name implies, fall between the first 2. They're still a bit of a mystery, with only a few discovered, but each is thought to have a mass of between 100 and 100,000 suns. These are thought to be the black holes that merge to form the supermassive variety. Not only do black holes explain the seemingly chaotic movements of some stars and contribute to our understanding of our galaxy, but they also represent a new realm of physics for scientists. According to Einstein's theory of general relativity, matter warps time and space, resulting in gravity, and black holes are extremely dense conglomerations of matter, resulting in their incredible gravitational pull. But from then on, they literally put Einstein's theory to the test. Things get complicated when we look at the singularity of a black hole. The forces at work are so massive that science cannot agree on what happens next. According to Einstein's general theory of relativity, when the matter is drawn into a black hole, its structure is destroyed, but quantum mechanics speaks against the phenomenon. As a result, black holes provide a fantastic theoretical playground for astrophysicists and mathematicians attempting to reconcile the two theories. Black holes provide experts with a testing ground for fundamental theories that explain how the universe works, ranging from general relativity to quantum physics and string theory. As the black holes have such strong gravitational pull that no light can escape, they cannot be seen directly. As a result, massive radio telescopes and gravitational wave detectors are used instead of traditional telescopes. Albert Einstein proposed in 1915 that when objects move through space, they create waves in space-time around them, similar to how ripples move across the surface of a pond. Then, a century later in 2015, researchers at the Laser Interferometer Gravitational Wave Observatory discovered gravitational waves for the first time. This was caused by the collision of 2 black holes 1.3 billion years ago. Black holes can be found by observing their effect on the environment. They suck in gas, dust, and stars, which become superheated and emit radiation, which can then be seen as a heat image. In April 2019, the Event Horizon Telescope, an array of 8 ground-based radio telescopes specifically designed to capture images of black holes, captured the first image of a black hole and its shadow in the galaxy Messier 87, part of the Virgo galaxy cluster. The image depicts a bright ring surrounding a black hole 55 million light-years from Earth that is 6.5 billion times bigger than the Sun. This halo represents the heat emitted by hot gas swirling around the event horizon, the very edge of the black hole, as it is drawn in. So here's the big question. What if you fell into a black hole? To be honest, whichever type of black hole you choose, the prognosis isn't great. If you jumped heroically into a stellar mass black hole, your body would undergo a process known as spaghettification. The gravity force of a black hole would compress you from head to toe while stretching you. As a result, you're stretched like spaghetti. A supermassive black hole has a slightly less horrifying effect, so imagine you choose one of these to make your great leap for humanity in scientific research. Sagittarius A star is a supermassive black hole at the center of the Milky Way, estimated to be 44 million kilometers across and containing 4.31 million solar masses. Two astronomers, Bruce Balick and Robert L. Brown, discovered it in 1974, but did not name it until 1982. After crossing the event horizon, the point of no return, your journey into Sagittarius A star would begin. You could see out from inside, but no one could see you because any light would reflect back onto you. The good news is that while the gravitational pull is much stronger than that of smaller black holes, the stretching tidal force is lower, so you won't be turned into spaghetti. The bad news is that you wouldn't be able to escape. Your only hope is the theory of white holes. Simply put, if a black hole sucks things in, a white hole spits them out, wherever that may be, and the two are linked by an interdimensional tunnel known as a wormhole. It's also possible that if you wait long enough, the black hole will turn into a white one. This process is expected to take billions of years, but don't be worried. Why? Because of the intense gravitational forces within, time would be accelerated for you, and it would be over in milliseconds. Of course, for the time being, this is just a theory. Consider the 2014 tidal disruption detected by 3 NASA telescopes as further evidence of the inadvisability of swan diving into a black hole. It was caused by a star passing too close to a black hole at the center of a galaxy, approximately 290 million light-years away. As it was sucked into the singularity, it was distorted, stretched, and shredded, while the remnants of the destroyed star were flung out in a cosmic belch. Given that our galaxy alone contains 100 million stellar mass black holes and that our own galaxy, the Milky Way, contains a supermassive black hole so massive that it would fit inside the orbit of Mercury 17, perhaps it's time to learn more about these enigmatic phenomena. Black holes are as dangerous as they look. Even if you travel in space for a long time, it's highly unlikely that you will ever see one, but now you know what happens if you find one. Did you find the video interesting? If so, here are 2 more videos you'll probably like. That's all for today. Please leave a like on the video and share it with your friends.